people. So now I give my beautiful introduction, and you guys will need to give me a sec. I thought it was so smooth until a second ago. Thank you. I did a good job of that, right? Okay. Awesome. So welcome everybody to our June event. Woohoo! I love you guys are matching my energy. It was the pizza, right? It really helped. I know. For you guys that are watching afterwards, you got amazing pizza today. Um, Let me see. Yeah. So here's our schedule for today. We'll begin by making introduction about our community. So whoever is here for the first time can be included on what we do. Then we will have an introduction from our host, Spice Academy, and we're very grateful for them to be hosting and provide us with this amazing space. We will go to our first talk by Laura. Laura is amazing, and we will introduce more about her afterwards. And we'll take 10 minutes break. Right after, we're gonna have Oiku right over there, another amazing lady that you guys will hear about more later. We will wrap up and open for everybody to mingle, and we'll try to kick you all out by 9:20. So let's have high hopes. Awesome. So, Pi Ladies, we are around the world, and it's really cool. We are an international mentorship group that for marginalized genders, and we provide this community to help people from all walks of life to be able to integrate into the tech community and make the tech community, the Python community, a lot more diverse and inclusive. Our mission is to promote, educate, and advance a diverse Python community through outreach, education, conference, events like this, and social gatherings. PyLadies also aims to provide a friendly support network for gender minorities and a bridge to the large Python world. A lot of the women in tech that I have met through here, and it has been such an amazing experience. And I know that a lot of other groups come here to find support and find how to get started or to just increase their knowledge on Python and so forth, or share it with us too. So who we are? We were founded in 2013. We have around 2,307 members, and we have 6 chapters in Germany, and hopefully growing with more people adhering to the PyLadies community, creating their own chapters, whichever place they are at. What do? We have regular monthly meetups and talks and workshops, like the one that we're having today. We sometimes do full day workshops depending on different topics. We have done some workshops about learning how to do open source or how to participate in different parts. We were thinking on probably doing something about Docker in the future, where we teach beginning how to do Docker. And whoever is willing to give a workshop about something, please let us know. We would love to host you so you can teach other people about the stuff you know how to do. We set up events to get started with coding. We connect people to companies, and anything that we can dream and make it happen, and we have the time for it, we'll try to do it for y'all. Okay. I love QR codes. Here's one for you. If you do not participate in our Slack community, but you would like to, please participate with us. Anybody is welcome to participate in our community. And we have a worldwide community on our Slack. So you just go and find City Berlin, that's us, and you can get notifications of what is coming up. You can make questions. People post their other events that are happening through the city that they would like to invite the other PyLadies to come. So if you would like to get more engaged with the community, feel free. If you have the time and you would be willing to help organize events, we would love to have you too. Our organization meetings are open to anybody. We have them in the first Monday of the month. So our next one is going to be the 3rd of July. And it's fun because you get to meet people, cool people like me, thank you very much, companies, and you get to develop your presentation skills. You just have a lot of opportunities because you're participating with us. And you get to lead the community, help guide the community in the direction that you also think it's best. Haha. We have speakers, but it is even more awesome if you can speak for us. So please, if you have something that you would like to share, come and share it with us. We have, again, a beautiful QR code that you can sign up, and it's a form where you can put what topics you would be interested in, a little definition of your talk. We are more than willing to pass through a dry run with you so you can feel more comfortable on how to present, and we will give you all the support that we can to make people that are going to be speakers for the first time, or if you're an experienced speaker and you just like to share with the community, come and share with us too. You know, we love to have everybody. So we have another event on the plans for July the 16th, and we would like to invite you all to come at too. These are the two talks that are going to be happening. One is going to be from Ana Paula Gomez, and she's going to be talking about another bot story. So a Valentine's Day gift to my girlfriend using GitHub Copilot workspace. The other one is our wonderful Jessica, and she's going to be speaking about how I use generative AI and ML in my work and side projects and why I think you should too. So making it better for us to have a better understanding on how to use ML in our daily work. Oh, I feel betrayed. I used to have a QR code right here too. If this is your first time seeing this presentation, you don't understand the sadness of this. We have a QR code, but since I don't have it, you have also a way to get to it. We will fix this for future generations, okay? Either way, you can come and create your own PyLadies avatar, and it's really fun. You can use PyLadies on your computer too, as you can see, and let's share our PyLadies uniqueness with everyone. We have a code of conduct, and we ask you please to adhere to it. We believe knowledge is for all, and at the same time, our event aimed primarily to empower gender minorities in tech community. By attending one of our events online or in real life, you also agree to the code of conduct. PyLadies is dedicated to providing a respectful, harassment-free community to everyone. We do not tolerate harassment and bullying of any community member in any form. If by any chance you feel any form of harassment or you feel like something here made you very uncomfortable, please reach out to us. We are in Slack. You can find us in LinkedIn. You can find us anywhere, or you can send a message and you can look at their code of conduct. We have a place there that you can submit an email to us. We really want to make this a safe and welcoming place. So if anything happens, let us know, and we'll make sure the next time it doesn't happen again. So thank you. That was the most important part of this presentation. But we like photos. You like photos too. We will take photos of you. If you do not want to show up in the pictures, let me know or let Jessica know or Anastasia know, and we'll make sure to take you out of them. But we will be taking pictures, just so you know. Okay, now, before I present our next speakers, let's listen from our host, Spice Academy. Hands for Anastasia, please.
Hello, everyone. Welcome. I need to stand in front of the
Yes.
camera. Yes, okay, then I will push you out of the way. This is a PDF that I will scroll through. It's not really a presentation, but welcome, first of all. Just to give some information before I introduce where we are, I wanted to say the kitchen is over there. It has pizza and drinks in the fridge. There's also a water dispensing machine, but all the cups are, I think, somehow dirty. So if you have a bottle, you can put some water in the bottle, but unfortunately, crockery is not available at this time. We also have some toilets just around the corner. Basically, if you go around this corner and you walk until the first door, you cannot open. The toilets will be to your left and the right. It's not very far. And if you have any other information that you want from me, Wi-Fi passwords, whatever, reach out and I'll tell you. So, welcome to Spice Academy. For those of you that have never heard of us or ever been here before, we are a coding bootcamp right here in Berlin. Also, we have online classes, and we fast track your future by providing 12-week courses in currently these topics. So we do data analytics, data science, UX, UI, web development, Java, and AWS, which are not 12 weeks, they're a bit shorter. But if you're interested in learning about any of these topics, you're very welcome to reach out and ask. We are a bootcamp, a community, a melting pot. We have a map over there on the wall, which is like a scratchy map, and people have scratched off all of the countries that they're from who have passed through here. And as you can see, there are only very few places left unscratched. If you find that the country that you most relate to is on there and hasn't been scratched off, I will let you scratch it off. So apart from providing the courses, we also do things like Friday drinks, we have fun graduations, we have summer parties, we have events called Spicy Food, where there's something about eating chili sauces and ask 3 questions. If you're into chef, that would be the place to go. And we have networking events as well sometimes. We have, I don't know how recent this information is, but we have 48% female students, 50% female staff. We have an alumni community of over 2,500 people and 122 nationalities in the community, though I would say that probably based on the map, I would guess it's a bit more by now. And we also provide some career support, networking, and sometimes a mysterious sounding event called Career Cupid, which I can tell you more about if you want to ask. These are some companies where previous students work, and you can get it financed by the Bildungsgutschein, which is the most common term. Otherwise, we have self-paying and also some subsidy options. That's it from me. Welcome. If you have any questions, let me know.
Perfect. Now I get to present our awesome speakers. So this is Laura. That's Laura. And Laura is a very technical designer. She is a founder of Davies AI. Okay, if I kill these names, you guys know that anything related to AI right now has really crazy names. So just endure with me, okay? Davies AI, and the human behind Switch Summer Child Score. Ethics Litmus, that she's laughing her head out if you can't see it. Fairchive. That is not on C. Okay. The Melbourne Fair ML and reading the Melbourne Fair ML reading group. Lara is passionate about feminist design rights and designing for privacy. She speaks at rights and runs workshops at the intersection of design and technology. Please put your hands together for Lara. She doesn't have the big.
I do have a dongle. Can you hang on to that?
Yes.
Thank you. Sorry about the mic. Cool.
Can you pass it to her?
Yeah, and I just need to share the screen as well. Okay, should I just share my whole screen? Is that what I was saying? Yeah, I was gonna. Let's do it. Amazing. Hi, everybody. Wow, I really smashed your eardrum. Sorry about that. Yeah, so thank you for that amazing intro. And also thanks to Timna for doing a really nice run through with me last week. I was all like, oh, I've talked so many times. What can I learn? And oh my God, she pointed out lots of really useful things. So the talk is way better because of her. That's a really nice thing to get to do. So that's nice from PyLadies. Yeah, so just tiny little bit about me. Oh, also, all my slides are live. I will also share the link at the end. If there's anything in here that you want to actually check out later, check out my slides, or I'll share them at the end. So a little bit about me. As mentioned, I am a designer and also a programmer and kind of just a spelunker of ideas. I think that's like the easiest way to think of me. I was recently a product lead at Explosion AI, which are the folks who did Spacey and Prodigy, working with Fernando and my husband Andy, because nepotism. But also he's amazing. He's an amazing programmer, but also nepotism for sure. And yeah, I'm really interested in machine learning. I've been sort of thinking about this big space of how do we do stuff that is both useful and makes money and just isn't evil, doesn't suck, like just isn't too bad. And like this seems to get harder and harder as a question as capitalism gets worse, but we'll have a beer afterwards and get into that. But just some things I've done is mention I did this FAIR machine learning rating group, and we looked at questions like, is debiasing, which is also the name of my company, Debias AI, but I need to rename it because I've come to the conclusion that debiasing is not actually the right thing to do. But again, that's a different talk. But yeah, questions of like, can you debias so that machine learning models don't learn sensitive protected attributes when they're forming classifications? Counterfactual fairness, which is a field I'm really interested in. I love this researcher, Alex Hanna, who was one of the really great team at Google AI Fairness that then got canned because, again, they suck. Along with Timnit Gebru and a bunch of those other really amazing researchers. I also facilitated going through the practical data ethics course on Fast AI, and if you are interested in this field, this is like a free MOOC. It's really freaking good, so highly recommend. So anyway, that's all to say, I've been thinking and working in this field for like 5-ish years already, and hopefully that will make you believe that I have something useful to offer and I'm not just some random person being like, hey, I want to do AI ethics. Because I'm sorry, there's a lot of those folks out there today, and I'm a little cynical. Okay, shall I stop being spicy for 1 second? Who here has heard of Game of Thrones? Put your hands up. Okay, everyone's heard of it, great. Has anyone watched any Game of Thrones? Like a little bit, cool. Has anyone heard this term from Game of Thrones, a summer child? Like half-ish? Okay, so in case that's not familiar to you, summer child is a child who is born between winters. So you can have these long summers that last for years, and they've never seen winter and they don't know what can go wrong. So if you're wondering what this reference is, it's a summer child, right? There you go. So just to land that, this is me and this is you. Okay, so how did I come up with this project? I started thinking about this like many years ago, but back around 2017, 2018, there was a government initiative in Australia where I was living at the time, which was called robo-debt. And robo-debt is kind of a pejorative term, and it's kind of as mean as it sounds, but essentially it was an attempt by the tax office to claw back support payments it had made to people who were struggling. Anything from 5 to I think 7 or 8 years out they went. So they would go back in your tax history and try and determine if they had overpaid you at any point in the last 5 to 7 years. And they did it. Yeah, I know, that face you're making 100%. They did it with, this isn't even the story of a like crazy machine learning automation with like really black box mechanisms and stuff. It's just a terrible, like simple calculation. They basically looked at your history of payments over a year, and they cherry picked one fortnight, which is just 2 weeks, one fortnight where you'd made some money, and then they multiplied that to be like, this was your annual earnings. And of course, anyone who has ever worked any like periodic or cyclical work knows that that is not how people get paid. They might get a ton of cash 1 month and nothing for 2 months. So for most people, this was by no way like an actual representation of the income they had made. And a lot of people at the time, and again, I remember this very distinctly, 2017, I had lots of friends in the digital rights community who were like, this is actually shit, this is not okay. This is gonna cause a lot of harm. And they were really pushing back. And they created this really great website called Not My Debt, where people came up and shared their stories. And people, we're talking about vulnerable people who are not by any means well off now, getting debts that were like 3 grand, 15 grand, sometimes even 50 grand, where they had no idea that there was any money owed. And it had very, very severe consequences. So you can read more about it on Wikipedia if you want to depress yourself, but like high-level notes, people lost their lives because this was so upsetting and so disempowering to them. And the people who were chasing the debts was this very sharky company that was like a debt collector. So if you've ever like had a credit card go into default, these are the people who like will send you just really awful letters that are like, you will pay us now or we will steal your firstborn child and smash their head against a rock, like that kind of shit. So these are very, very like intense, unsympathetic debt collectors. And this automation went from very, very bad algorithm to debt notices with nothing in the middle. So at the time, I was asking myself, hey, we knew this was a bad idea. Why were these arguments not successful? Is it even possible to make more clear, rigorous, and compelling arguments that sort of ground the intuitions that everybody I knew had about what could go wrong? And is it possible that we can avoid these kinds of problems in future? And I will say, like, in this case, the answer is probably no, because let's be clear, it just came out about a year ago that at the time this like policy was enacted, they had advice from their lawyers that it was illegal. So the people in the government who were doing this thing knew that it was not legal at the time, and they were still like, cool, let's just do it and see what happens. So like, even if they didn't care about the human impacts, even if they didn't care about the fairness of this thing, they should have known that they couldn't do it, and they still decided to go ahead. There was a number of like legal pushback against this. We ended up having what's called a royal commission, which is like a big formal law review, like looking into the policy and deciding whether it was okay to do or not. And it was again declared illegal. There was also a class action lawsuit, but again, all of these things are long and arduous and exhausting for everybody involved. So like, what would have been better is if it never happened in the first place, right? So, oh wait, sorry, keep going. So like, even acknowledging that in this case, probably couldn't have moved the needle because, you know, the lizards wanted to be lizards, and that's just what was happening. I'm sorry, it was for my husband. But I do want to argue that even if we can't move the needle in every instance, we can still do better at having these discussions for ourselves and our teams as technologists. And I think it's important that before we convince others, we must first learn to convince ourselves and each other. So as technologists, my argument is that we should get better at forming our own opinions on the kinds of risk and the degrees of risk in the systems that we build. And I'm going to acknowledge there's actually quite a lot of tooling out there for things like observing unfairness across protected classes versus, or like across groups of people, demographics of people, and for doing things like data governance and data fairness checklists. So there's a huge world of tools out there, and you might be like, well, hey, Laura, why another tool? And my intuition is that it's very possible to get into the weeds and, you know, work out what kinds of policy to apply to your own tools, your own technology, your own stack, your own model. But it's actually harder to step back and go, okay, well, let's think about our system in the context of the world. Let's think about our system compared to all the other systems that our users might need to interact with. Let's think about the specific people that we're going to be interacting with or predicting over. And like, for me, I hadn't seen anything that really encouraged this kind of thinking or helped me do that in a rigorous way. So this is my attempt to do that. So Sweet Summer Child Score, what is it? Timna told me it was totally unclear what it was. I'm gonna try and make it super clear, and then I'm gonna check with you before we keep going. So it's a self-assessment quiz, which gives you a risk score at the end. So you answer the questions on behalf of your system, your tool, your technology, your model, and at the end you get a risk score. It does a thing which is just trying to scan in a fairly rigorous way for what kinds of harms could happen. And at the end, you get also a list of things you could do better. So there's this section in the middle is like all sorts of levers that you can push on as a technologist to improve the visibility of your system or reduce the risk of it. Okay, does that make sense? Do you get what it is? Great, awesome. And it's online. It's also something you can run as a package locally in Python. I thought it might be fun to run it in the CLI, and it's also nice for like if you have a sensitive topic that you don't want to put on someone else's data servers, like you can just run it locally. It's also in R, it's also in Rust, and what did you write it in recently? You haven't put it up recently yet. We have one more package coming. Zig. Zig, because ultra nerds, I don't even know who uses in Zig, but that's it. Yeah, so this is like the various ways you can take it. And it looks like this if you're taking it in the CLI, so it's just a bunch of questions and then you type in your answers. So if you like that kind of thing versus a web quiz, it's kind of fun. Ooh, and I want to do some fixes up and make like some cool animations in ASCII art for like between the questions. So I have a bunch of ideas on how to make it even cooler. Okay, so algorithm design, let's talk about it. Or as I like to think about it, formalizing my opinions into code. So early on, when I was sort of thinking about this, like, again, I was thinking about RoboDebt, like, is it possible to avoid this problem in future, or just like, have better, faster, like, arguments where we have like clear points we can talk to? It's like, this is wrong because X, this is going to harm Y, this is going to cause Z. So my questions were things like this: how many people could be impacted by the system? How can you do relative risk ranking? Like, how can you, when harms are like hard to quantify, right? Like, I can feel, I don't know, dismissed by someone at a meetup, but that harm is probably not as bad as a CV scanner kicking me out of the queue because I have a feminine name, right? Like, their harms are, they're hard to quantify in the absolute, but we should still be able to go, we kind of care about this one a bit more than we care about that one, right? Also, what about things like imperfect information? So if you know any game theory, this is just saying we may not know the future state of the world or exactly what our tool will like affect in the world, like what changes it will cause. I was also asking myself questions like, what if it happened to my mom? So like, would that be okay with me? Does this sound like a Black Mirror episode? Still one of my absolute favorite questions. Also, that little tool that Timna mentioned before, this is a project I created called Ethics Litmus Tests. And it's literally a little test tube with a bunch of questions in it, which are sort of motivating questions to help you interrogate your gut. Essentially, when you're sort of going like, oh, maybe this is not the best idea. How do I how do I scratch that itch? How do I find out? So just a bunch of questions in here which are like, does this sound like a Black Mirror episode? Maybe we should rethink our life. Also, like, would I want to be known for this? So, is this something that I want on my CV? Would I make it into a case study about my work in the future? If the answer is no, and also, gosh, I hope no one finds out so I don't get prosecuted, like the team that literally made it. Yeah, I mean, like, again, strong signals, right? Oh, sorry, keep going. I've gone to the wrong spot. Sorry. Sorry, go forward. Here we go. Okay, I was here. Other questions I was asking myself, like, what obligations do we have to other people? How can we reduce our risk by design? Which choices do we have control over? Because again, like, I want to be really pragmatic that there's a bunch of things we can't impact as little people, and that's okay. There's still some things we can do, and we can try and make choices which we see as normative. And by that, I mean, we're showing the world how we think it should be by doing the right thing. And from all those questions, I kind of ended up clustering them into 3 main sections. And they are a cohort scan, a system scan, and Maslow's hierarchy of needs. And we'll go into them in a second, but I'm going to talk a little bit more about the scoring mechanism first. So they're all worth kind of 1/3. And this is basically a Dolly quiz. I don't know if you all were like teenagers in the 90s. Yeah, thanks, Jody. We appreciate you. But this is like, it's not a complicated scoring mechanism, but I think it's important to talk it through because you may disagree with me. You may want to make a version of this where you weight things differently or you cut the score down differently. So I think it's important to like break it down even if it's fairly simple. So I start with a multiplier. And that basically just draws on this intuition that a system that impacts 10 people should be less risky than one that impacts 1,000 or 100,000. So that's pretty straightforward, right? And this multiplier, it just is used to like take the total score that you've gotten and reduce it or keep it nearly the same. So for the small cohort sizes, like 100 people, you can see that it like almost divides it by half, and then it gets up to about 1. And it's kind of like, if you plotted this, which I probably should have done if I was slightly more organized, you would see it's kind of roughly a sigmoid curve. And that means that like we're sort of flattening out towards the top here. Because essentially, like, once you get over a certain size, it's just a lot of people, right? You're impacting a lot of people, so I don't see the like change in risk being high, whereas like the change in risk at this level is very high. And how am I calculating the score? Well, we start with, so it's kind of like a test paper at school, but instead of starting with 100 points, you start with 99. So I deduct 1 because we're in the real world, and also it made my scoring work, so for 2 reasons. And then so as you answer the question, you get assigned a score for any given choice you make in the multiple choice, and you add up all those points, you times that sum by your multiplier, so like it gets reduced by some amount based on the impact you have, and then your total score will be 99 minus your adjusted sum. So if you got 40 and then it's by 100 people, so it get 20, then your score is going to be like 80-ish, right? And the lower your final score, the higher your risk. So if your score is 80, 90, you're actually doing great. If your score is like 60, 70, you're middling, and if you're in the 20s, you should really, really step back and think hard, because there's a lot of risk going on. So you might also ask me, why even a quiz? Why a score in the first place? And it's a great question, and I want to acknowledge that we're asking subjective-ish questions and hard-to-answer-ish questions because we do have imperfect information. We don't know everything about how our system will affect the world. So I use it essentially as a MacGuffin, a way to like drive you to the end and make you do a thing. Like if you just had like pages of random questions, you'd be like, oh, why would I do this activity? But if you have a quiz and at the end you get a score and some next steps, it feels a little more motivating. So to me, it's just a way to push you through the process and invite you to do it and continue doing it, because like everything in this field is just a capacity to develop a skill as opposed to, like an inherent good or an inherent bad. Like, we all work on systems that have ethical impacts, and some of them are good and some of them are not so good. And that's okay. And the job for us to do is to acknowledge that and try and get better, and not be scared about not being perfect, because no one is, and the world is not perfect. Okay, let's get into it. So the cohort scan, this is basically asking who could be negatively impacted by the system. It's not limited to end users. So when we say a socio-technical system, we mean all sorts of people. So it could be the people that the system makes classifications about or predictions about, and they may in no way interact with the final product. I'm thinking of like insurance actuaries where they like make lots of predictions about our future health and our death date and all this other fun stuff. And we never see that data, but it certainly impacts our insurance premiums. There's also people who train the system, so that could be labeling data or otherwise like tuning the weights, interacting with the model. Also people who operate the system, so not the developers of the AI, but people who are administering it going forwards. Also people who pay for it, I probably care about them the least, I'm not gonna lie, but we can still consider them in the scope of our socio-technical system. And there's also end users of the system. Sometimes there will be like an app or a tool that you end up using. Think of like a recommender, like Netflix sending you your next movie or TV show to watch. So you might ask at this point, why wouldn't we scan for minority identities? And I thought hard about this, and my answer is, I would prefer to focus on the harms that we're worrying about, the disadvantages, rather than the demographics of that disadvantage. And essentially, it's an attempt to avoid conflation of a minority identity and harmful impacts, because we don't really want certain people, like women of color or disabled people, to be always thought of as like people who experience harm or people who have a bad time. Like, we want to focus on the results of the system, what we're trying to encourage, what we're trying to avoid, and we can do that without ever thinking, or without necessarily scanning for like the demographics, ethnic, like gender expression, etc., like, or any of those things. So just to try and ground this, I wanted to kind of come up with some examples just to sort of help you understand why we want to do each of these sections. So imagine you're doing fraud detection in an insurance app. So you're trying to work out, someone's trying to game the system. When you're doing fraud detection, this is actually a field I've worked in, you often end up with these signals, and the signals can either be a bad actor, so someone really actually trying to commit fraud, or it can just be someone who like is kind of an outlier in the user population for some reason. So for example, if you're a VPN user, It could mean that you're trying to hide something, or you're just a really confident techie and you care about your security. And it's easy for these features, these signals, to sort of be conflated as only fraud. Equally, if you don't use two-factor authentication, it could mean you have low-tech confidence. Thinking about all of my aunties and uncles, and like they have a hard time with this, and it's not fun for them. And this is also something that can be flagged as fraud, but it's also something that can just be a user who's having a hard time. So if we do this work of cohort scanning, then we can think through these use cases and start to have some plans for, well, what do we do if we misclassify someone? How are we going to improve their user experience? How are we going to help them recover from that event and make it as smooth as possible to come back and be like a normal user again? So if we kick them off, or if we freeze their account or do something else to them, we should always acknowledge the possibility that we fucked up, right? That we did it wrong, and we can help them like recover as quickly as possible. So let's have some example questions, just to try and ground this as much as possible. So one question in this section is your target cohort economically vulnerable? So in this case, I'm just thinking like, think about a baseline for the group that you're working with, like the region, who's earning what money, and then you just kind of like compare your target cohort to that group, and you go, okay, they're kind of in the median, or they're pretty high, or they're a bit low. And if you don't know, you just kind of go in the middle. Similarly, you ask questions like, is your target cohort over-policed or over-surveilled? And again, this is asking this question of, are they more likely to be targeted by policing systems, by any kind of image, facial recognition, anything like that? These are to ask the questions that if this is already a problem for this group of people that we're going to be building a system for, we should be ultra sensitive not to exacerbate that harm. We should be really careful to think through those things. Next section, we're going to do a system scan. So this is looking at this question of the implementation of your system, your technical tool in its context. So I think of it like the shell, like the bit where your tool like pecks through and like starts to interact with the world. And I love this section, it's really powerful. And it's because it gives us all these levers, these options that we have as technologists to both observe and mitigate risk. So to give a case study of what this could look like, imagine I'm building a film recommendation tool for a company that sounds like Netflix. Imagine that I'm like, ooh, I'm going to be a really clever data scientist, so I'm going to like incorporate some news topic scanning. So I'm going to try and like, not only find out what people like to watch, but try and like pitch them some ideas that are really timely based on stuff that's happening right now. So like, if there's like a soccer match, for example, like there's all the soccer happening, you might give people like some Ted Lasso because they're interested in watching soccer related things. And that's going to go great until it doesn't. So what if like your data drifts in production? What if you have a black swan event and something goes bad, or just not even a black swan event, just another COVID? What could happen? So I could imagine this case, like suddenly all you end up doing is suggesting that people watch Outbreak, Contagion, and Pandemic over and over and over again, and that could be a really bad time for people who are already maybe locked down or otherwise worried about a virus. So the point of this is to say, we ask these questions of ourselves to be like, okay, well, what happens if like, extrinsic factors change to this point that we have like a really bad outcome? Like, what do we do? And for me, the question is like, can we take it down? Is it possible to get it out of production so that we can go away, tinker with our weights, tinker with our model training, and come back? And yeah, a lot of what we do in system scanning is asking questions like, can it be taken down? So yeah, can you turn your decision system off instantly if something goes wrong? And no, I don't mean, can you write and deploy some code and then take it down? I mean, can you click a button and take it down? Often it's nice to have a backup, like some kind of baseline, a simple version of your system. So you can just have a thing that recommends the top 5 movies of the month. And that's not the worst recommendation algorithm you could imagine. So there's lots of ways to have a very simple, like, piece of logic that's, the simple version of your complicated model, so you don't even have to tell your users that you're offline. You can just have something there, so in case you start seeing some weird behavior in production, you can take it off. Another question we ask in this section is, does your system always output a classification, prediction, or decision? Or can your target cohort request a decision review? So again, we're asking these questions that help us like intuit what we could do as technologists to make these things more robust, more observable, more like good computer science hygiene. I'm nearly done, I promise. I blame Timna for this talk going out because she's like, oh, we have some time and I want to hear some more, so I added a bunch of extra slides. Okay, last section, Maslow's hierarchy of needs. It's a little bit updated, but it's essentially, has everyone heard of this thing? Like, yeah, okay, good. So yeah, we care about whether we impact people's ability to live, of course. We're basically asking ourselves, if our system didn't exist versus if it did exist, like, are we going to directly impact any of these 5 tiers? And you know, like, again, this kind of scratches at this big, deep field of causality, right? Like, we're not thinking of second and third order effects. We're not trying to think of like the long, wobbly causal sphere where you like drop a pebble over here and then a butterfly flaps its wings in Japan and then something over there happens. Like, we're not trying to map that in our minds. We're just trying to think, you know, pragmatically based on the interventions that my system can make in the world. What could I see going wrong? What could I imagine could happen? And yeah, like this section I'll acknowledge is trickier because we don't have so much visibility, so we do have to use our imaginations a little bit more. But I recommend that you trust your gut. So imagine you're building a time series model. Everyone know what time series forecasting is? Yeah, mostly? Yeah, I mean, we're basically trying to like have a model to predict forward like things like, you know, revenue forecasting or planning logistics and shipments and that kind of thing. But it's essentially like trying to plan for trends over time. And imagine you're building a thing which is trying to work out when your hospital is going to need additional staff, like supplementary staffing. And this is always going to be this trade-off, right, between trying to save the hospital as much money as possible by not paying for like supplementary staff when they don't need it, and the patient's right to care. So this is an example of a system where if you get it wrong and you have no way of finding out that it goes wrong, you could actively like prevent someone from getting care, which is, you know, at the base of your Maslow's hierarchy of needs, which is your right to be well in your body, to be alive, to survive, to get medical care when you need it. So yeah, I want you to really like ground that you don't have to be a big evil government or a big evil corporation to actually like ask these questions and often find pretty like pointed answers to them. Like, I think most systems have some like matrices of harm, some like vectors of harm rather, like if you really like kind of dig in and think about it a bit. So some example questions that this could look like are with your physiological needs. You're asking the question like, will your system directly negatively impact your target cohort's physiological needs? So that's right to like breathe clean air, have clean water, have food, have shelter, have sleep, reproduction, and of course, be alive. Like, being alive matters. I think so, yeah. And then at the other end of this, at the tip of the pyramid, we have esteem needs. So these are things like your ability to feel respect, to like grow as a person, to have good self-esteem. And then you have all the ones in the middle. Okay, so to summarize, is this algorithm design perfect, or is this quiz scoring design perfect? And like the answer is, of course, definitely not. And is there room for improvement? Like, absolutely yes. Please, please, please help me. I would love some contributors to this project. But I think it's a starting point. And I would encourage you to like take it, to fork it and extend it, to use it for things like if you, for example, were working on a system that didn't predict over people, but was looking at objects or animals or an ecosystem or plants. Like, you could imagine taking the same questions and trying to reframe them for the context that you're working in. You could also maybe like cut out some questions and put in some more pointed questions if you're in a specific vertical, like health or social media or finance. Like, social media isn't going to care about many of those questions, but then all these questions around the right to know the truth, the right to see like a consistent world with your peers, like these are things that you could add in as questions. And I'm sure there's other vulnerabilities I have not covered here. This is just my go. And of course, you might disagree with my scoring, so you're welcome to adjust the weights and reflect your own priorities. So yeah, please fork it and use it. And if you need ideas on how you could use it to assess a new feature or a product idea, so something like in its nascent embryonic form. You could use it to review competing features, to critique existing solutions. So that could be like, even from the outside, like the nice thing about this quiz is that you don't really need to see the guts of the machine. You just need to make some kind of calculated estimates of what's going on. So I also quietly think this could be useful for journalists because it would help them form some intuitions about what's going wrong and like how to critique a system from the outside in. And if you're a technologist, you could use it to have some plans for what your harm mitigation techniques could be, or to find a comparative point of difference. So if you want to be like, hey, we do great things, and also we're not evil with your data, or we'll delete your data once we've like formed our classifier, so you don't have to worry about us storing it forever. Like you can use this kind of thinking to work out how you want to behave and how you can use it to differentiate yourself from other players in the field. Oh yes, and then I'm going to quickly try and, oh, can I get out of here? Yes, I can. Hopefully, can you see GitHub there, Jessica? I hope. Oh, share this tab instead. I got it. Cool. Okay, so I need to do some grooming on this repo. I'm really sorry. I meant to do it before today and I didn't get there. My plan is to put up a projects page with some issues. So if anyone wants to contribute, they are welcome to. But basically, I have a Python library, which is kind of the main repo spot. And you can see it's very simple. You have your Python quiz here, which is literally just the logic of the questions that we just talked through. I lost my, can I go back? Okay, I'll just do it like this. You can see and hear like all the weights of all the questions. So once we go into, you can see the scores against each of these questions. So if it gets a point, you can see the point is assigned in here. And there's also a PDF, which explains it a bit. But yeah, I mean, honestly, even if you just came to this repo and were like, I don't understand X, and sent me a message and told me, Laura, help me do X, that would be really helpful to me because I need friends to improve, and it's hard to know exactly what people need. And I will share the links again, like at the very end, and we're almost done, I promise. So we're at GitHub. That's me. So those are the two big links, the slides, LinkedIn, and then summertrial.dev is actually the landing page that also takes you to GitHub with all of the sub-repos. And hopefully you can find everything you need there. Thank you so much for your attention. Do we have time for questions? Does anyone want to ask any questions? Maybe? Okay. Yeah. Do you want me to run the?
There's a second mic behind you in the box.
I can bring you around the board.
Thank you.
Do anybody have any questions?
Yeah, we have.
I was wondering, it was really interesting and really fun. I have two quick questions.
Of course.
One is regarding, you mentioned that after evaluating like a certain aspect of the feature, like this level, the CLI does provide a solution or suggestion of a solution. Is it a closed book document I provided, or does it use any LM retrieval system?
I think you're thinking this is way cleverer than it is. Thank you for that question. It is literally one way only. You give it some information, and then if you say, I have not got a way to take it offline, at the end it's like, hey, did you think about taking it offline easily? So everything where you answer in the negative in the system scan, like all these levers that I mentioned that you can push on, it essentially suggests that you should think about that. You should try and incorporate that into your system design. This is not intended to be like installed in your your data pipeline for your machine learning model. This is just for you to assess the risk of your tool and sort of try and form your own opinion about whether it's okay. Did that answer your question?
Yes.
Great.
And, second question, the last question. So I like that you also mentioned in the end that it can also be used by journalists in criticizing features that other companies or groups have built. And I'm wondering because OpenAI and OpenAI as the current police recently came out with an open letter, right?
Mm.
Saying that us developers should be the ones that disclose those information, disclose their risk level to the general public. And I'm wondering, did you got this with intention to grow the community that can kind of be like the Glassdoor for risk, anonymous risk evaluation?
And that's an amazing idea. Let's go build that. That honestly, like, it wasn't really my intention, but I think that's a really good point. Is that there's a lot of, I mean, we already see this from people doing things like sharing their salaries in public to like whistleblowers saying, "Hey, this isn't okay. We have a problem with this," and everything in the middle. So I suspect you're completely right that there's a real appetite for people inside big companies to try and warn the public when they are concerned about something. And I think some kind of glass door about risk for AI is a great idea. I mean, this could certainly be used as a way of like framing those warnings. If you were like, yeah, I did swimmer child and I got a 20 and these are the things I scored badly on. And then like, plus here's my paragraph on why I'm worried it's bad. Like I could certainly see that being really juicy. So yeah, let's talk about it after. Any other questions, I think, or how are we going on time?
Does anybody have a technology question, or could we talk about it later? We're all could talk about it later. Awesome. So we'll take like 10 minutes. Yeah. Okay. We'll take a 10 minutes break really quick, and then we'll go back to our next talk. Okay? Get some pizza, get something to drink, and then we'll be right back.
because there's more. In addition to professional pursuits, OIPO is trying to give back to the community, sometimes as an organizer, sometimes as a mentor or volunteer. With a belief in the power of community involvement to make a positive impact. Please put your hands together for her.
Can I take this? Okay. Hi everyone, my name is Öykü and welcome to my talk about generators in Python. So this was a very last minute presentation. I'm not sure if I'm ready. I never had a chance to do a dry run, so we are doing it together now. I first want to know my audience. Anyone here, like raise your hand if you don't know what generators or iterators are. Good. If you know them but you're not feeling comfortable. Okay. If you know them but you never use them. Okay, good. You are my audience today. So if you know them, very good. I'm sorry, you have to bear with me. We will go through the basic stuff. Yeah, my name is Öykü and I'm currently a software engineer at Up42, a child company of Airbus. And I'm mainly focused on backend development. But currently I am a geospatial engineer, which I didn't know 10 months ago. Yeah, I don't know if I am one of them, but I'm trying to. I am an organizer, mentor, volunteer in a couple communities. I love being here. I love PyLadies. Okay, so before we start to generators in Python, maybe you don't know, there will be, in July, there will be a VR Developers Conference in Berlin. And I know generators in Python a little bit can be boring, so I wanted to, make my slides interesting. So I prepared a Slido quiz. Whoever wins the quiz will get a free ticket from us. We have 5 free tickets. One of them we're giving away tonight, and you can still join the raffle. With that being said, let me open Slido first. It was open, but it is closed. Sorry about this. Yeah. Okay. Yeah, you can join, but you won't see the questions just yet. Yeah, we will explore them as we go. Great. Okay, I will change the screen. So if you haven't taken a picture yet or joined, is it okay if I change the screen? Okay, good. Okay, so why generators? Why this topic? I recently had a friend who got into an interview and they asked, what is the difference between generator and iterator? And she told me, I had no idea. So I realized it's a good interview question and it's a good topic to give a talk about. And they are really useful if you want to work with large data sets in a more Pythonic fashion, especially useful when you have data sets so large that it's overwhelming your machine's memory, or a complex function that needs to maintain an internal state every time it's called. And the function is too small to justify creating its own class. Okay, definition. Generators, a generator in Python is a special type of function that returns an iterator which yields value one at a time, allowing you to iterate through potentially large sequences efficiently without storing the entire sequence memory. So yeah, I know this doesn't make any sense, so we will get through that. But here I say it returns an iterator. I mean, we know what function is, but what is an iterator? Let's start with that. Iterators are, okay. In this talk, I will say iterators, iterable, iteration, a lot. Get used to that. So iterators are objects that allow you to iterate over iterables, which are lists, tuples, strings, dictionaries, and sets. And you can get an iterator from any iterable in Python by using the iter function or iter dunder method.
any term. For example, here I have numbers array. Calling the iter function with numbers array gives you list iterator. It's the same with calling the bundle method and the iter function. And if you call it on strings, you will get a string iterator. Okay, what is next? Once you have an iterator, you can start getting its item one by one using the next function or the next bundle method. Here, for example, we have numbers array again from 1 to 5, and I created our iterator calling the iterator function, and it's my iterator. And we call next, you got the first item. We call next again, we got the second item. We call next again, this time I use bundle method to show you it's the same. We got the third item. Okay. And so far, so questions? Like, okay. Okay, let's see our first question. I am asking what would be the output of this function, this method. Here we have a list iterator, places iterator. We have an astronaut who's carrying important data to different planets and moons. And we want to see if, we want to see where his or she is visiting. So first, we will call the next, and again, we will print resting, and then we will iterate over the iterator. So here, oops, sorry. Is it? This is my first time. Okay, what would be the output? There's no time limit to the question, so I will wait 10 seconds. Sorry, what? Zoom. Oh, I don't know if I can. No, I can't. Sorry. You can come. Yeah. Okay, I think this time is enough. I don't know how to lock the question. Oh, yeah. Okay. Okay, I will reveal the answer right now. I don't know how to look. How to, yeah. No. Okay, let's do this. Okay, so if you haven't responded yet, this was the last time. Okay, the correct answer is this. Sorry, you said something?
I think if you click next, maybe it'll, I don't know.
No. So yeah, this is the correct answer. Why it's not printing the second one? Because we said Europa takes on here the first item next and the second item next, and we run a for loop. So you might expect to see the second one, like the loop starting over again. It didn't, because the iterators are stateful, meaning once element is consumed from an iterator, it cannot be retrieved again. So here, if I can, let me see if I can do this. Yes. So this next called this one. This second next called this one. We printed resting. And now, when we came here, our for loop starts with the next item on the list, and so on. So that's why we didn't go with the second one. Okay, let's move on. Trying to. I am really trying to. Is it the problem? Yes, okay. So we are iterating until when? You'll get a stop iteration exception if you ask for the next item, but there are no items left in the list. For example, here we have Jupiter and Mars, and if you call next, you will get a Jupiter. If you call next again, you will get Mars, and if you call next again, you will get a stop iteration exception. Okay, so let's see. Conveniently, all iterators are also iterables, meaning you can get an iterator from an iterator. Therefore, you can iterate over an iterator as well. Yeah, so we did this. We created places, the moons and the places, planets, and we have places iterator. So for place and places iterator, you can iterate over the places. You'll get the list of the places. Okay. So they are so similar to lists so far. Why not just use iterables like lists? There's a little comparison here. In memory-wise, iterators generate items when requested, therefore takes up less memory, while lists store all the elements in the memory by default. Evaluation. So iterators are lazy evaluation using lazy evaluation, computing each item one at a time when you need them. But lists are immediately evaluating them. Therefore, performance is much better in the iterators, and the length of the iterators can represent infinite sequences, but lists, of course, must have an finite length. And versatility. This is my favorite. With iterators, you can define your custom iterators that you can loop through custom logics like Fibonacci sequences, for example, or prime numbers, but with lists, this is very limited. Okay, so I want to show this in an action. Let's move on to here. Yeah, okay, you can see it, right? I can close this. I will drop the microphone. Okay. Let's import system. Thank you. Thank you. Okay, so I will get size of places, and we will do the same for the places iterator. And if you can see, the places iterator is taking much less space than the list itself. I think this is cool. Thank you. Okay, so they are so good that Python secretly uses them when iterating over lists or dictionaries or any other iterables. What do I mean by that? So let's see what happens behind the for loop. The for loop converts the iterable to an iterator. It repeatedly calls the next function on the iterator to get each item and stops when the stop iteration is raised. Can I have you again? Thank you. So here we have our places array again, and for place and places, we are printing the place. Let's write this code in what generator does, in what for loop does behind the scenes. So what we said here, we said for loop converts iterable to an iterator. So let's convert our iterator. Let's create our iterator. So here we created our iterator, and we need to have a loop here. And we said we will print it every time by calling the next function on place iter. But we have to stop somewhere, so we will get an exception. And we will get a break. Thank you. So this is what for loop does in Python in the background, which we don't even see. I can't move on. Yes, okay, so creating your own custom iterator. Here I created one custom iterator called my iterator, and let's see it. So we initialize it with start value and end value. Every iterator needs to have iter function and next function. We already know that. And iter function returns an iterable, so it has to return itself because it has to return an iterator. This is the iterator class, so it has to return itself. And in the next, we will have to get the next item. So we are going through some logic here. We have to have a condition to stop, to raise the stop iterator. So here we are saying we're checking if the current is less than the end value. If it's not, if it's less than the end value, we increase the current, return the number, and if it's not, we stop the iteration. So you call it like this: my iterator 1 to 5, and if you say for a number in my iterator print number, you will get 1 to 5. It's much like a range function, but range is not an iterator in Python, which is also a common interview question. Why it's not iterator, I don't know actually, but it returns an iterable object, not an iterator object. Okay. Okay, so summary. Iterators are objects that allow you to iterate over iterables. They have two main methods, iter and next. They generate items one at a time and only when required, rather than all at once. And they are stateful, meaning they remember where they are during the iteration. Okay, Slido, next question. So an astronaut, we have the astronaut again, is carrying an important data to different planets in the solar system or the moons. Here we have the places and places iterator, and let's check if some planets are scheduled for a visit. This Titan in places iterator is a Boolean, so either it will print true or false. Let me go to the next question. Okay, everyone, okay. Good. Okay, so what would be the output? Sorry. Okay. I think it's enough time. It will print true, false, true, false. Because Titan is in the place accelerator, of course. Earth is not there. It will print false. Mars is in there. It will print true. But if we call Mars again, it will remember. I mean, the printer is like, not printer, sorry, pointer. Pointer took Mars out already. So it's stable. It remembers where it left off. So if you call it again, it will return false. Moving on, another question, and let me move on to the questions here. Okay, everyone's okay. I don't know why I'm presenting now. Yeah.
I think that you need to put next first because otherwise, if you say this is correct, everyone's.
Yeah, true. Thank you. Okay, I will do that. Makes sense. Okay, so here, it's a very similar question. First question, we have our constellations right now to study the stars. And we are traveling through the constellations. And for constellation astronaut visited, what will it print? Am I on the correct question on Slido? Yeah, okay. Yeah. I just wanted to see, sorry. Yeah. I am about to move on. Okay, there's a tie. Okay, nice. Yeah, sorry. Okay, so the correct answer is astronaut visited Orion multiple times. Why? Because here, I did this on purpose. So here we are creating our iterator once again from scratch in every for loop. That's why we're not even like trying to get to the second item on the list. We are always getting the first one with the next because we always get a new iterator in every for loop. Okay, so this was iterators. Now we can move on to the generators. The same definition again. Okay, so function side, we are okay. Generators are actually a function, and that they are returning an iterator. We know what an iterator is at the moment. They yield values one at a time, which is already what iterator does. So there's nothing new here, allowing you to iterate through potentially large sequence efficiently without storing the entire sequence in memory. Okay, everything is the same. But they are much simpler to create than custom iterators. We use functions. We don't need to have a class, and we don't need to define iter and next methods. Instead of defining them, you are using the yield keyword. What it does, it allows a function to return values one at a time, pausing the function, saving its state, so that it can resume where it left off when called again, much like reading a book. So my favorite book is Wuthering Heights, and I really love it so much, but it's so intense. So the passion is like the emotions felt by the characters is so much. I want to finish it in one go every time when I open the book, but I can't. Like I need to take a break. So instead of reading it all at once, I of course use a bookmark, like put it on the table when I'm done, and I'm getting back to it where I left off. So think of a regular function as someone handling you the entire book all at once. You have to carry the whole book around with you, which can be heavy and cumbersome. But with generators, it's like someone giving you one page at a time, or like using a bookmark to remember where you left off. So this would be what a normal function, regular function, represents in my head, at least. You get a whole book with, of course, finite amount of numbers in the array, and you get the whole book, and you read it by page. But this is how a generator would work. So you would get the item, so you would get the current page one at a time, and every time you get here, you get the current page, and then you move on, you get the second page, you get the third page, and fourth and fifth. Okay, so far any questions? Okay. Okay, so this is a break for me to give myself some pep talk. Let's run this together. This is I think I have it here. Let me check. Nope, I don't. I copied here, and I came here. Nope. Yes. Okay. So here I have give complements generator, and I am expecting to see a couple of them here. So initialize the generator by calling the function, and I am reaching the items one by one. Here it says you're doing great. If I do this again, sorry, it's really hard to do it one by one. Okay, so one too many. Okay, yes. Oh my God. Yeah, okay, so it says you're doing great, this presentation is amazing, and it's not boring at all, and we're all learning a lot. So we are getting all the items one at a time with yield. Okay, so that actually worked. So we're moving on. How to generate generators. Besides using the yield keyword, you can also create generators using generator expressions. So this is how we would create a generator in a normal way. And this is how you would do the same thing in using generator expressions. So it's much like creating a list, but instead of using the brackets, you use the parentheses. That's it. Oops, sorry. Okay, so one thing that is really good about generators is that you can have two-way communication. So imagine that our astronaut is on a space mission again, skywalking to a distant planet, and we are in the control center monitoring the astronaut's actions, and we need to communicate with her. To send commands and receive reports, like a walkie-talkie, we need a two-way communication. And for generators, we can use send. With send, you can send a value back to the generator. The value is received by the yield expression. This is very important. You will see that in the example. The value that we are sending will be received by the yield expression, where the generator is paused, and the generator resumes execution and continues until the next yield expression. So with yield, generator communicates with us, but with send, we can communicate back. Let's see an example. Okay, I forgot this. Yeah. Okay, so as an example, here we want to say to our astronaut report, and when we say report, we want to hear back, I see a distant planet. When we say scan, like you command, you order, we want to get scanning the planet for the right time. So this is what astronauts would say, this is what we would say in the control center. So we are, so while true, we are getting command yield, listening command. So what you have on the right side of the yield is what your astronaut, your function, tells you. And what you have on the left side is what you will store as a variable when you send your value. So if we say something, our value that we send will be stored in the command variable. That's why I underlined here by yield expression. Okay, so I mentioned this. This is what the listening commands are, and how astronaut is talking back to the control center, yield something, and it breaks. And this is also how astronaut talking back to the control center yields actions get command. If command is not found, command get not recognized. Okay, let's see how to call the generator function and communicate with the astronaut. Do I have it here? No. Okay. I can copy this. Oh no, I already have it. Yes. Here. Okay. So this is the same as you saw in the presentation. Here we created the generator. You have to prime the generator, which means start the generator and advance it to the first yield statement, which is here. You have to do that, it's mandatory. This is necessary to set up the generator to receive commands. And after doing that, if you call mission.send, so your generator.send report, you will get, let's call this. So, no. Okay, current file. Okay, yeah. So you set report. What you should see is that I see a distant planet. This is what we see. Yeah, okay. Here you have to, after each send, next is called to prepare the generator again to receive the next comment. So you're telling your generator to go back to the yield again. And if you say scan, you will get the scanning the planet for life science. Or let's do this one more time because I think we have time. Photograph. Our next comment is photograph, and we should get taking photo of the stars from the astronaut. Okay, moving on. Yes.
Sorry?
Yeah.
If we run the same command that has already been used,
Mhm.
according with the reasons to not have it accessible anymore,
Great question. Let's do it.
could you repeat the question?
So the question is, what happens if we call the same command again with send? You don't get an issue because it's something we are sending to the generator, not that we are reading it from or an iterator. That's why you see listening commands taking photo of the stars. We are not taking anything from an iterable object. We are giving a command to it. We are providing a value. But great question. Yeah. So, okay. Your question number 4 and the final question. So here we are collecting the samples. Samples collected 0, while true, we are going to receive a comment from the user. And if command is end, we will break. If not, we will collect. So this is how we call the generator. What would be the output? I will start this and we'll move on to, yes. Yeah. Okay, I will now stop it. Yeah, if I do this, yeah, okay. So the correct answer is error. This was a trick question because, yeah, normally you would expect to get the first one. Yes, I understand. But I mentioned here that sorry, not here. Yeah, here. I mentioned here that this step is mandatory for you to be able to send values. So you didn't have to prime the generator in this example. That's why you will get an error. Okay, so you can also send an error to the generator using the throw method. It's basically the same with send. You can use .throw with an exception. It's helpful to break your while loops in the generators. The error is received by the yield expression again, and where the generator is paused. But I won't be going into detail because this is the, second talk of the day, and it was, I think, quite intense. So I won't be. I don't have the energy for that. So sorry. So let's have a final slide. Let's have a summary. So generators are functions that use yield to return values one at a time and maintain state between iterations. They return a generator object when called, and they use yield to pause the function, returning a value and saving its state. And they need to be primed with next or send none to start. And you can use send value or throw exception to send values or exceptions to generator and receive outputs. Generators end with return or when all items are yielded. You again get a stop iteration when done. Thank you. So let's see who won here. Okay, Fernando. Okay. So the conference is 17th July, between 17th July and 19th July. If you're not available, we will go through Elena. But find me, Fernando, afterwards. Okay, so that was it. Thank you for listening. Any questions?
Hey, how good was it? She wrote that talk like, what, a day ago? Like, wow. Just really good work for having
Thank
talk like it up in 5 seconds. When you're sending something into the generator, where does that get stored and like how does that get stored? Is it just like adding to an array or like is it, like if I send something in which is like help and then the next thing is like actually I'm wrong, but is that getting overwritten in the variable or is it like added on at the end?
Yeah. Good question. So I always gave the example on lists. That's why you're like immediately thinking, oh, am I like adding it to the list? But no, we don't always have to have lists. I show them as an example because they are very easy to iterate over and see the iteration over by your eyes. But no, the yield expression holds the values. If you assign it to a variable, your variable holds the value. Does that make sense? If you provide a list to your generator, the variable that holds the yield expression, here I can show you, here. So if you provide list to Space Mission, for example, your command variable will hold that list. If you provide a string, your command variable holds that string. Yep, make sense? Okay, good. Thank you. Yeah.
Can generators change size as you're iterating over them? So let's say you're doing streaming and more data is coming in. Can that join onto the same iterable?
Yes, that's so dynamic size is what generators are for, and that's why it's very useful in memory efficiency. Yeah. Okay, I'm terrified for the next question. This is getting harder and harder to respond.
Any more questions? We could hear for nightmares.
Okay, thank you.
Let me just put it here.
Yes.
Okay. There. So now the people on the screen can see me too. Everybody gets the privilege. I promise I don't have half as self-confidence as I say I do. Okay. So just for your closing, we're very, very grateful for all your presence today. I hope you guys learned a lot with us, or with these amazing people. I learned a lot with them today. Or I have been, as you heard, I have heard a dry run before. Either way, as we commented before, we're opening for speakers. If you have something to share, you saw some examples today. You can go through our YouTube and you can watch many more. But we're always open to have new people share what they know with us. So please feel free. We're more than willing to help you, and we'll love to do a dry run with you. I learned a lot by watching it twice. So again, upcoming event, please be here next month. We will love to have you all back. And now we're going to skip through this. Get in touch with us. Here's some forms. Again, a QR code because, again, we love it. And we hope to see you guys next time. Please talk to us if you want. And thank you. Oh, we have speakers. Take speakers home. Show us around. If you like me, a good example. Okay, see you guys.